Morning everybody. I know I've been promising to do a video about using API, and I thought what I'd do today is use both things to my advantage. Now, as ever, I have my trusty set of calipers with me. The what I thought I'd do today is stepper motor geometry. You can get different sizes and things like that, but what I'll aim to do today is just focus on the main geometry itself and roughly to where hole mounts will be and things like that. Then from there, what we could do is, I'd need to get some more geometry, but we could look at different size stepper motors and make this system scalable. But without further ado, let's kick off. So what I intend to do is first get the geometry into position. Now this is a NEMA 17. It's something that I'm working on for a complex pan and tilt system, but I thought what I'd do is just go through that process of actually physically making it. So what I think as well, thinking about it now, I will do the geometry, and then I may do another video based on this stepper motor again, and then combine different functions within it, so look at different variations and things like that. So I'll go new and part. You notice at the minute I'm not really focusing on making sure it runs first time and every time, just because what I want to do is just get my geometry working. So with my trusty set of calipers, let's see, let me make sure I'm in the right 0, here we go. Right, so according to this, on this NEMA 17 we have a diameter of we have a width of 41.96, and we also have another width of 42.4. just to give me an idea of roughly how big that's going to be. But what I do know is, really looking at this would be the next phase within it. But so I have a width, height, so basically it's a cube for a start. However, this cube has something a little different with it. As we all well know, it has chamfers. So as ever, I'm not going to go shortcut, I'm going to go top plane and sketch. Then from there I can choose which way I'm going to go. I always like to use the datum as a reference, so I wouldn't click anywhere over here. I'd locate to the datum as my first start. Get that into there. Right, now I'm personally, as I've said before, I don't like to rush in feet first. So what I'm going to do is I'm going to drop here and put on chamfers and just get what I'm after. So what I'll do is put only one chamfer on. It's interesting just because I want to show you exactly what's going on. So I'll click on here, then click on here, and I'm going to confirm that, and then I'm going to what a wally, not a good start, forgot to hit record. Let's start again. So again, record, top plane, sketch, and bringing in my corner rectangle, then going up to, see, it goes to fillet. I mean, for this I want a chamfer, and I'm going with the top edge here. A few things we need to examine about that chamfer, you see, and that's why I'm only putting one on. So I'm going to hit stop, and I call this stepper motor, then click OK. Right, okay. So as ever, what I would say is cancel this drawing completely, because we're going to make sure everything runs. I'm going to go to edit and then bring in stepper motor. So what I'll do, as you can imagine, I've got this hiding in the background, playing around with chamfers earlier, so you can see there. Now, typical setup, what I would suggest, as I always try and suggest, is, whoop, not that, is, come on, there we go, stepping through that process. So I'm going to click in the main body, F8, and just step through. So I went to top plane, insert sketch, clear selection, it's put on for toggle view, but that's just my setting. I'm going to go corner rectangle, clear selection, selects line 3, selects line 4, which in this case is the line that's you can't see here. Clear selection. Now that's just to ensure that all memory is clear and that it's a proper default setup. 3, 4, and chamfer, and then end. Right, let's just take a quick look, make sure that ran as I originally intended it. It has. So now, because that code executes through and there's no little niggly things going on, I'm now in a position I can start moving forwards. Interesting thing with this, now we've seen this before, a repeat process where it will go through it, repeat it, and go through it again and again. However, you'll have trues and falses that are being emerged in here. However, look here, this is a double selection method. So we have select either by name, and also it's recording the position in which I clicked. But interestingly, you can trick the system, changing the numbers will still reselect. But I'd always recommend just trying to get some sort of position as to where everything's sitting. So I'm going to start with my basic design, and I'll come up to here. I'm going to do I'm going to need a particular dimension, so I'm going to go dim W as double, dim L as double, and dim H as a double. Okay, so I'll go input box. I'm going to try and use pretty much everything that what we've seen so far, and I need to assign a variable to that. If anybody's already noticed, well done. So I'm going to go with. Trouble is, these aren't really refined, but what we'll do is do it anyway. So enter stepper width, and then I'll do a double tag. So I'm going to put my default in, and these will be the genuine dimensions. So I'm going to go a width of 42.7. So I'm going to go 42.7, and then I will just close that out. So what I'll do now is the same thing again, but for length. So I'll change U to L and U to that. So let's bring that in. So according to this, on the 42 point, well, we'll go 42 because it's a fraction of a change. So we're going to go 42. And then we're going to go height. Putting us at 47. It's not an actual perfect cube, because a lot of people think that they're perfect cubes, but they're not actually perfect cube. So we'll go 47. Damn it. Bring in double comma. 47 and close. So that gives an initial setup. Now with this, what I'll perhaps do is just comment that out, because I'm not going to be using that just for the minute, because I'm still only in basic geometry mode. Right, so we're going to go length, and I'm going to go width. So this is just a basic change I've made so far. I'm going to need to really refine this again and again, so let's just run that through first. Oops, maybe I should have put the new part in, but I'm going to step that through, In fact, I even almost made the schoolboy error, which I'm sure a few have already noticed. Set that to a units area, and then we're going to go W is equal to W over 1000. L is equal to L over 1000. Just gives us some sort of units for us to be defined within, because obviously the caliper, I'm doing it in mil. So and yeah, just want to make sure this is right. And that's given us that small initial units area. So I'll run that through. Yes, yes, runs through. Now what I'm interested in here is, as it executes, to give me that size. Line 3, line 4 selected, deselection. Line 3, line 4 selected. And the chamfer is a happy days as well, which is phenomenally good, really good. Let's just get a measurement on that chamfer. Now, according to this, the chamfer on this one is actually 7 mil, not 10. So, what I'd like to do is I'm going to say dim cham as a double, and I'm actually not going to offer this to the user because it's something that I need to have control of, but I don't want the user to be able to change this just because it's really going to be something that really what you would do is push this into a case statement, because in different cases it will be accredited to different values. So I'll bring that back, and in here what I'll do is say cham is equal to, well, it's going to be equal to 7, and then we'll come down to here and I'm going to change my chamfer to cham, and again here cham. So don't forget, this is each line point change, so we can even give variation on that chamfer also. So let's run that again. See, once this runs and it runs sweet, we will be able to execute that chamfer again and again, which is great. Okay, comes in, builds apart, both on selections and chamfer. So that's fantastic, it's great. So let's stop that, and then let's move on to the next piece with this. So we've got positions for 3 and 4, 3 and 4. Now, to look at efficiencies, what I'm going to perhaps do is drop here, and drop here, and drop here completely. I know it seems crazy, but I mean, saying that, actually, if you look, it comes into here. We could do with making sure there's nothing else selected. So let's clear that out there and then execute that chamfer build, because I think we can do away with that one entirely, but I need to just double check. So let's run it in. Yeah. Okay, so what I'll do is maximize that, and I'm just going to remove my section out here. So let's bring that back again, and I'm going to repeat this. It's a typical geometric change, but what I'm going to do is place my new chamfer 1 and 2. Now these reside, where I'm talking about here, these reside more in the lower area, and also I've just realized here as well. So where line 3 exists is, let's have a think. Line 3 exists let's just step that through. We're going to need to step that through because I'm getting myself confused as to where the hell am I existing. So if I run that through, oh, if that appears, by the way, this has appeared because 2 has been declared twice. So what I'll do is stop that, and I'm going to run it through. It's a chamfer. So 3 is my upper X, 4 is my right. So then it'll come there, right. So you'll see that it still did it. I just want to make sure though that existing positions are correct. So this will be, because this is the upper one, this will be W. Oh no, that one, sorry, that will be L. Let's have a look. So long, it's into minus, right, so this will be L. I'm going to go W over 2 because it's existing in the multiple plane. So I'm going to go W over 2, and then I'm going to try and repeat this process. All I'm wanting to do is just say where this line is. Say where the line is. Say where the line is. Whoops, that's just me just knackering that one up big time. And it's not there in this one, it's actually just thinking about this now. So L, no, it will be there. So this one will be over 2. All I'm trying to do is just give a rough allocation, locations to where these things sit. Just want to double check first before I even execute that, because if I've made a mistake it will then just refuse to execute that chamfer. But let's just double check. So run that through into here, onto there. Excellent. So I'll do the same thing here. Now on the lower ones, this one here is dead easy. This one here is dead easy. So so I'm going to go, I think, so 1 is to the left. So we're going to go W over 2. I'm going to set this to 0, comma. We're going to go L over 2 and reset that. And put this to 0, like that. Let's give that. Let's give, oops. Let's give that a whirl and see what happens. Okay, well, I'm quite happy with that. So we know chamfers now existing on both. Now all I'm going to do is take a copy of this, copy, and I'm going to paste, and one more to paste. Right, so we have 1 and 2, so this would be 2 and 3. 2, whoops, this will be 2 and 3, and this will be 4 and 1. 4 and 1. And this will become L over 2. Is it L over 2? That's right. And 3 becomes L over 2 and W. L over 2 and W. And then 4. Right, so let's run that through again. What we should have now is a full equal amount of sets being given. So we need to just check it. Just run it through and go OK, OK, and then we come in. Yep. 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 Perfect. So that's the initial bit that I'm happy with. One thing I do want to check now is a slight change in geometry. I know it's random, but if I change this geometry slightly, it's just going to make sure that I'm on the right ballpark. So I've just upped that up to 40. I'm going to go 50 on there. So we've clearly got a width now that is completely out of what initially our standards were set to. So that's a little bit on a change. So we've got chamfer, 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 and chamfer. Now I personally have always found this better. I've just always found this better to do it this way, because you look now, if we just zoom that in, you look now, that is what we got, and we're on fire. Right. So now what I'm going to do is hit record and go to phase 2. Go extrude boss base. Again, we are not interested about how much it's extruded by. What we're actually interested in is the geometry that it builds. So dummy. I love a good dummy. So I'm going to bring that back in, extend there. And what we'll do now is I need to go into edit and bring in my dummy, and that's all I'm after. I'm going to copy it, come back into stepper motor, and then come to the bottom, slight bit of an extension there, and then extend. Right. So what I'd like to do, I'm starting to build up a little bit of a little bit of areas, so I'm just going to put on a comment, stepper base drawing, and then this entire section is corner chamfers, well, chamfers. Sketch chamfers, I should say. Sketch chamfers. Then into here we'll go. You see what I'm able to do is when I open this again, because what we're going to do is we're going to save this and we're going to do a little bit more. We're going to do some ifs. We'll put a few things onto there to just restrict it. So I'm going to go chamfer, and then in here I'm just going to go stepper extrusion. Right, now we're on to the height. I'm going to bring in my height, and this is quite easy really. I'm going to go H, and then I'm going to go H, and that allows me now to jump straight back in. And you can see now some sections of this you seem to make so much progress, and then you'll almost be at a total stop. So I'll do new part. I should really add that new file in, but what we'll do for the minute, just run that through onto there, to there. Right, so onto that top plane. Sketches on, chamfers on, next chamfers on. Really, we could loop this, but it's not something we've done yet, so I'm just going to stay with what we've essentially done. Plucked out these position points. Now I'm going to go to extrusion and then close. So we're actually starting to form the initial first stages of our stepper motor. Yum. Right, now the holes. As anybody knows, stepper motors are very specific. They're incredibly useful. Really good bit of kit. I mean, really, there is a slight cutaway further in, and once we get into this, we'll perhaps put that in as well. What I want to do now is place my holes, my mount holes. Mount holes are so incredibly important because you get them wrong, and it's a total, utter, and complete nightmare. So, there's a few ways I can do it. So based on length and width, according to this, on width it is 4.76 millimeters by and width, length it is 4.37. I'll remeasure that again, but what we're going to have to do is place them into position. Now, this year in particular, Alex came up with some great ideas when it came to placing a drawing point onto it. So I'll go with Alex's method. I do really like it. So I'm going to go record, I'm going to go top plane, I'm going to go reference geometry and plane, and then just confirm that. We know from the experience that we had that can already be used as a height. We've already got that dimension there. So again, I'll go back in here, come into here and go to my dummy. My dummy folder has all my bits and bobs that I need for this. So I'll just come right up. That's everything that I need there. Look at that double selection process. We've seen this before. So I'm going to go copy and come back into here, and then again I just want to know where I'm going, so I'm going to go top stepper plane, bring that in, and it's quite an easy one here, H. But as ever, we've made a slight change, so let's just run it through them tests. And then let's just close that and start anew. I will add in the new part. I can feel the issues already. So I'm starting to get lots here. I don't want to step through all this. It's boring. So I'm going to left click there. That left click allows me to just break it at that point. So I'm going to go run. Yes, yes, yes. Runs through, builds it to the last point that we knew. Now I go F8, top plane selected. Ooh, oh, look at what you could have done. Now we had this before, so if I remember rightly, the upper point became our biggest hindrance. So let's stop that, start again, and let's take another look, and then let's run. Yep, yep, yep. Looking good, and plane's in position. I took the brake off just because I knew it would work. In fact, those of you who knew it would work, well done, because it's important to know these things. It really is. So this is a nice spot now. Now what we got to do is try and decide how the bejesus are we going to actually get the circle in position. We have 4 mount holes. We have a central hole. We have a central raised plate here. Then we have a shaft that comes up the middle, and then that'll be a nice finish, I think, for our stepper motor. Again, if you haven't, make sure you save this, because I'm going to come back to this in further videos. God bless nicotine. I'm not trying to promote smoking. Right. So, let's have a think. Let us have a think. I'm going to go record, top plane, and then I'm going to sketch. If you're ever thinking, I don't want it to look like that, I'm going to go Control and 8, and even the system recognises Control. Let me think. 1 to 8. Can't remember what the other ones do. You got different views, but you've got even earlier ones, and I can't remember what they do. Apologies. Right. So I'm going to go circle, and I'm just going to put a circle there. What we're interested in, we get one circle in the right position, we can navigate ourselves all the way around. This is closest to the datum, so because this is closest to the datum, it's pretty nice. So then I'm going to stop that, because we're going to stay in this sketch for a little bit. Yes, I want to replace it. So let's come into dummy, onto modules, onto dummy, and I mean, I know you've all seen this before, but that is all we need. So get back into here, and then let's call this mount holes. or top plane circles. Something. It's just because I intend to put some more on there. Well, we'll go mount holes actually. Mount holes, because we'll add another one in for the central shaft. So coming to here, right? So we need a diameter. Oh, excuse me. These look. Let me have a look. These are M3s. So we've got 3mm on this. We're going on M3. So first things first, let's get it in. Let's go diameter, dimension, and we'll call MS as double. Now they're M3s, so the user again does not have an option. I know I'm taking lots away from them at the minute, but we're going to add later. So we're going to M3. I mean, with this we'll go 3mm, and then as ever, to make sure our units are satisfied, we'll go MS is equal to MS over 1000. Right, so let's get to the bottom. Right, so we need the position of the circle. Let's have a think. Let us have a think. Right, so just had a little bit of a look online at stepper motors. The central mount plates, they actually are a fixed sizing, supposedly. So the NEMA 17s, this plate size is actually 30 by 30, but if there is any you can have variation on the external casing. These mount holes must remain at that size for a NEMA 17. That's why you can pick up some NEMAs and they are ever so slightly different. So what I'm going to do is come back up to the top, and we're going to have to define this as a dimension. We're going to have to, but we'll call this M stand as double. So what we're going to do is we're going to create a hypothetical square coming from the center of the circle. Now this is where it gets really bloody confusing. Right, so we need M stand setting. So I'm going to bring that in to here and say M stand is equal to 30. Apologies. Because the standard on these is 30 by 30. But if that external casing changes, we still need it to be 30 by 30. So we need to pull the central axis of wherever this body is to make sure 30 by 30 is always there. So it becomes irrelevant as to who would make it or how many would make it. This mount plate is our biggest concern. So go M stand is equal to M stand over 1000, like that. Right, so this is where it's going to get very tricky. So I'd always recommend commenting out the original circle, because you may come back and go, how the hell did it work from the start? What I'm going to do is I'm actually going to copy that and paste it straight in. So we now just want to put things into position. So let's check on my drawings, L and W, L and W. Right, so we know X is defined by length. We need it from the center of the rectangle. So I'm going to go comma, just because, I mean, a lot of people say you can do it without it. I've just never had any luck with it, so I always just put this in. So I've got L over 2. Okay, so we got the center of the circle. Now, just for argument's sake, I'm going to put these into brackets as well. Then I'm going to go minus brackets M stand, which is my standard sizing, which in this case is 30mm, over 2, comma, to close the argument of M stand over 2, comma, to close the whole equation process, and that should give me my first initial position. Should do, I say with a very nervous comment. So I come back into my second, and I'm going to push that into there. Whoops, I'm going to push that into there, place that in, and here, because it's square, this is the only real thing that we've got going for us. We just changed there because we know it's going to be square from the center of that corner rectangle. So let's bring that back, jump it across, and interestingly, I've been asked to do a pan and tilt for a stepper motor, and there's all we were going through some stepper motors yesterday. They are all over the place. However, this central plate is not. This is predefined by a standard, so hence why we're doing this, and I thought it'd be a nice example of something that you may need to do. I'm going to hit run. Right, duplicate current in scope. Yes, all it's saying is, why the hell have you defined that twice? And it's because I'm gradually building it. So let's run that again. Yes, yes, yes. So this is the big bit. Now the initial size of the circle may be incorrect. What I'm interested in is the center. If the center's bang on, happy days. Look. Yeah, well, I mean, I did say. So let's go Control and A. Let's just make sure this wonderful person, being me, is correct. So we'll come on here, and what we're actually after, because you'll notice I'm coming from here, I almost nearly made the mistake myself. I'm actually going to draw straight onto here, because I want to make sure that I'm roughly in the right position. So I'm going to dimension from each point to the center of the circle, nowhere else. So go to the center. Oh, I'm still in. My system keeps defaulting its units, and I think it's because I've also been using Inventor. And Inventor just seems to be telling everybody, I'm the boss. Look at that, look at that, look at that! 15 by 15. I like to say it in the best possible way, nailed it! Now, that's far from nailed, that's completely wrong. But the beauty is I've got a position. It means my initial calculation of where that should sit when that changes will be the same. Happy days. Now, I know some have said, well, why don't you just mirror it across? No. No, I'd rather not. I'm getting annoyed with this, so what I'm going to do is fix this now, hit record, gone new, gone part. If any of you are uber wanting to know how to automatically open the new part every time from anywhere, I'm not going to do this in these tutorials just because it's the way of solving it is absolutely delicious, and I don't want to spoil that for anyone, so I won't be doing that in this. It gets I've had some students very annoyed in that process, just trying to get it going. But once you solve it, I swear to God, it's so satisfying, it's unbelievable. Right, so I'm going to drop that out. You can see here, I've got it here. So that's a dual declaration. I'm going to remove my count because I'm going to let solid work. Well, I think Dassault have mastered this CAD stuff they talk about, so I'm going to trust them in what they're doing. And now at least I don't have to keep messing around with clicking new and new and new and new. But I do need to keep getting rid of parts that are obsolete. So let me just double check. Silly please, sword. Right. Run that in. New circle in. Fantastic. Fantastic. So, let's get back across. Let's get looking at this next circle. So we know that's here. Now, if you remember, I always said before, we need to choose which direction that we'd move in. So, this section is our initial position, and all we're going to do is add further to it. So I'm going to just highlight the whole blooming thing. Gonna, oh, in fact, let me just, I better bring all of the arguments in. So it's there to there. Right. I come back across, and I'm going to just bring all of that to there. Right, so we're going to go with that. I mean, I always like to operate in the X direction. You can go in the Y if you wish. My standard in this case is MS. So then this would be calculated out. So let's have a look. L over 2 minus M stand. Give the position. Close there. Then all I'm going to do is, ready for this big stuff, plus MS. I mean, to be fair, don't forget, draws in radius, MS over 2. So when it's coming in as a radius, and we need to make sure that's right. So, and the 3 mil it refers to is a diameter, not a radius. So, what we essentially do now is, right, sorry about that, guys. I've been introduced. I've been interrupted for the past, let's have a look, 2 hours, and I was hoping to get this finished a lot sooner, but apparently not. So, last time I ran it, I need to run this again, just because I'm not even sure where I had got up to. So I'm just going to run this through. Check this in, right? So we got to the stepper motor section, and you may have found this. Argument not optional. Now this has come from an input from me, and I have made this mistake, so we need to track along where I have made this mistake. So we're going to go X, comma, Y, comma, Z, comma, right, X, comma, Y. Now when I was on this before, it appears I've actually accidentally deleted the Z value. So if I'm just going to add a 0 in there, when you do this for your assignment, you're gonna get so much fun with this, just because this thing happens and gets very tricky. But let me just close that and run this again. So run this through, size. Right, so we have a hole. Nice. So I'm going to just dimension that. You see, I mean, it's at 3. It's really irritating me, is this? Ever since I've installed Inventor, everything keeps defaulting itself to meters. Right, so we get back to it, and I'm happy. 3 millimeters. That is fantastic news. Okay, so what I'm going to do now is I want to try and repeat this process 3 times. Now the beauty is we've got the geometry already here. I mean, we've got the command already initialized here. So I'm going to put that in, and put that in. So just to remind me, I'll go 1, I'll go 2, I'll go 3, and I'll go 4. So why not? Whoops! I tell you, already made mistakes, and now I've got 4. So what I know is these are the hole mounts, and that's the 3 positional points that's in control. So what I want to do is I'm going to drop that down, and drop that down, and drop that down, just to help me digest exactly what it is that I'm doing. So now I won't lie to you, in front of me I've actually got a very poor drawing of what we're actually doing. So if you think about it, the first first position, the position of this hole, is where we're most interested. So it's L1 over 2, which puts us to the lower, and it's minus M stand. So if I leave L1 over 2 minus M stand, it still keeps me in the lower left. And then where I get to W over 2 minus M stand, if I change that and go plus, so then I come across, where are we, over 2 W, and we go plus. Now again, this won't work straight away, so I'm going to break it, and then I'm just going to snap into here. Oh, or not. My goodness, what's going on? There we go. Right, we'll snap into there, and then let's run this again. This gives us a next position, which I'm pretty confident we're going to be good on this one. So let's run this through. Yes, yes, yes. Step. Excellent. Step. Excellent. And then the other two will just give me continuous here, because we need to move them, don't forget. So I'm just going to get rid of that. Let's come back in. Now I'm very confident right now. Well, confident-ish. So that's onto here. Now where we've got here, if I just copy that, and if I actually just copy that, and the reason I'm doing that is it gives me a reminder as to I'm going to start from the last hole, and then that tells me that with L2 I'm going to plus M stand here as well, and with L2 here I'm going to plus it, and what it's going to do is it's going to shift it along into the next position. But again, let's just run that through. What I'll do is I won't step it, I'm just going to execute it, so my code's not changed, just off the screen. So I run it, ask me for my inputs as ever. Perfect. Now you see this second line, it's gone tangent because that hole, I've not changed it yet. So let's come back again. Now this is quite good. Right, I'll show you something. What I want you to do is I want you to replicate exactly what you just did, but opposite in every single symbol. So I'm going to go plus, I'm going to go minus, I'm going to go plus, I'm going to go right, let me get this right. It's this thing now. My goodness. Now I think that's right. Let me just double check. So I'm going to run this again. 2 seconds. Right. On the lower end of the positional mount hole, it's actually there, I think. The last one went wrong purely because the position of it was clearly completely out. So I'm going to run that again. You see that here? This has occurred because the circle is trying to sit on that tangent. So if I zoom into that tangent, you'll notice it sits on that hole mount and also on that hole mount, and it's purely because it's on that right point, if you will. So run this again, just double check that's working. Oh, happy days. Right guys, so you won't believe this, but I've just been interrupted for 5 hours, so now it's actually 6:30, but we are going to get to the bottom of this process. So let me just catch myself up. If you look at where we're up to, here I've made modifications and now the whole thing runs. Now I cannot remember if I'd shown you on that fix just because it was such a while ago. Now take a look at here. Just double check my method. If you're not sure, make sure you hit pause, have a zoom in and just double check. Okay, so when I execute it, this is now what I get. I've got my pattern, I've got my mounting holes. what I'm going to do is go record, extruded cut. Now this extrusion, we're going to go 10 millimeters for the minute, doesn't really matter. Click OK, and then again I'm going to stop. Put that into my dummy. Yeah, I want to replace it, so bring in my coding, come to the bottom, and we have, come on, there we go. That, you'll see the feature cut, same principle of what we've seen before. Now we have dimension object my feature. What I'm going to do is actually just copy the lower, because that declaration of my feature has already been declared here. So all we're doing is we're re-establishing and reassigning that task. So I'll put that into there. Right, so what we need is, we'll actually leave that extrusion at 10 millimeters. We can leave it at 10 millimeters, or well, I'm not sure. And when I'm not sure, I think it's best that we put in a dimension. So I'm going to go dimension. Okay, so we're back in action. Now, I've got my cut. As I was saying, could do a dimension. Now, if I go dimension, and we'll just call it MD as a double. This now establishes my depth, and now looking from the depth of me putting in the calipers, I'm going to go MD is equal to 13, interestingly. 13 millimeter depth, which is quite hefty, I must admit. But these are stepper motors. They aren't the lightest things in the world. So I'll go MD is equal to MD over 1000. So I'm now operating in that comfortable slot. And I go down to my extrusion, and I'm going to go MD. Now, you're probably thinking, well, what's the point of putting that in there? If I just neglect it and just go, because it is, what if somebody comes along and says, well, we're changing the extrusions? What if I have an area that allows me to deal with all them values? Hence what we're looking at. So this is the reason that we'll still do it regardless. Now, that's in there. I'll close this, and I will run my execution. Boom, boom, boom. Phenomenal. So let's just double check. Bring it in. Yeah. So we're good. We're all in good stead. So finally, what I actually want to do now is bring in the final shaft. Now, this is the central drive shaft. Now, interestingly, for those of you who don't know, who may even not even care, the housing around a stepper motor is, well, they call it the resting ring around where the central shaft is. This is standard. So we need to ensure that the ring itself remains standard. Without it being standard, we're a bit knackered. So, let's get it in there. And we're at, according to what I'm measuring, we're at 22 millimeters. Again, if I'm wrong, this can be modified because we're in API. So I'm going to jump it back out, and I need some more variables. So I'm going to go dim, cent, ring as double. And as I said, this is at 22 millimeters, so I'm going to go cent, ring is equal to 22. And then what I can do is, as ever, get that unit converted. So, and then I come down, and we've got that. Right, okay. So we have shaft dia. So again, these shafts tend to be default, but if I wanted to introduce a custom shaft, I could do. That's what's the important thing on here. So if I go, so that's the shaft ring, then we're going to go dim, shaft as double. So we're going to dim shaft height as double. Okay, so a few things we're gonna have to do. We're gonna have to introduce a sketch onto our new plane. So we've got top plane introduction there. However, look at that. So we're gonna call this drive shaft. And I'm going to paste in my plane selection. So that's now into a sketch. And go OK. Right. So we're going to bring in a circle. And what I'm going to do is take all of this. I'm going to go 0, X, Y, Z. X, Y, Z. It's all my 0 markers. So we know the first is going to be L over 2. That's what we did. Close that. We know the second is going to be W over 2. So we've got that centre circle right away, which is happy days. Then we know that we need to have, let's start with the ring. We're going to put the ring in position. So we're going to go, let's have a think. We need the ring, what was the ring? The ring, the cent ring. So we're going to go for our XYZ, we're going to go brackets L over 2, delete that, plus cent ring over 2. Then finally this obviously becomes W over 2. Close brackets. Right. So let's just make sure that sits where we want it to sit. So I'll close this and then we're going to execute this again. Excellent. So that's our ring. So we need to know the internal diameter of this ring. Now interestingly, this actually comes in at just under, from what I can tell, 8mm diameter. Interestingly, this cutaway in every single design seems to be, well, this extrusion in every single design seems to be the same, which is great news for us. So what we'll do is we will say now all I've done there is I've drawn that to that, but what I'll now do is say ring over 2, open bracket, minus, open brackets, 4 over 1000. That should now put me in a position where I end up with an internal ring now. So let's run it again, just double check. So it runs through, should give me a second ring which is internal. Excellent. So that now right, I had to pause myself then. I've made a mistake. I went 4, but that's obviously going to give me much greater. So what I'm actually saying is minus 16. So I'm minusing 16 from that initial value. So let me just double check. Have I got that wrong again? It's been a long day. It's quite late now. So let me just double check. This is a great thing with CAD. I can just keep checking until I get it right. And of course, have a look. This units is driving me insane. Millimeters. 10 millimeters. Right. Just been bouncing my head backwards and forwards. Been a really long day. So what I've actually done, because everything's over, it should have been 7. I don't know why I was thinking otherwise. And when you run it with 7, you should get 8 millimeter as an internal shaft, which is what we're looking for. So what I really want to do is just want to now bring in that little bit of an extrusion. Now, for anybody who doesn't know, in this central point here, we have an extrusion of actually 2 millimeters. What I'll do, again, hit record. I'm going to go extrude, boss base, and this will become 2 millimeters. And click OK. And then stop. Into the dummy. And then bring it back. Gonna go dummy, modules, dummy. And I'm gonna bring in this. Into the drive shaft. Bring it in. And what did I call the ring height? I'm gonna have to call. I'll go center ring H. So I'm gonna go. There's a double. I'm gonna go center ring H. Whoops. I'm gonna go center ring H. And all I'll do here, where I've got center ring, I'm gonna copy, and I'll come back in here. Then go center ring H. And I'm gonna go H. So then this becomes, whoops, centering H, and because it is very late, I'm going to say copy, and I'm going to centering H there as well. You kind of go, yeah, right, okay. So we're on centering H, and I'm going to run it again. Make sure this runs. I mean, I'm pretty confident now. Oh, that didn't run. Oh, that is a bummer. That is an absolute bummer. Okay, so something went wrong. Yeah, just for me for this to go wrong right now. Okay, so let's go on extrusion. We got onto my feature. My feature's already declared, or else it wouldn't function. So what we'll do is, for argument's sake, I'm going to clear the selections because I don't want it to think that I'm trying to just extrude my last circle, and I think that's what it's trying to do. So before I get overloaded, let's get rid of some of this because there's a lot of it. Oh, you know what, I'm giving in. I'm just going to run it. So I'm going to run it and see what happens. Into normals. Still not happening. So now it makes me wonder if I've done a problem with my cent H extrusion. So centering H. What did I do wrong? Oh, look at what I could have won. Swear to God, I don't even know how fast my own shoelaces. I forgot to put a value in. Me thinking it was something wrong. Well, it was something wrong. It's something I did. So I go equals 2. Because, as I said before, we've agreed it's going to be 2 millimeters. Well, according to this, when I've measured it, it is 2 millimeters. So let's run it again. Ha ha! Happy days. So we've now got the housing, the bed. I've heard lots of variations of what this is called. So now that sits into there. Let's move on to the next bit. Now what I want is that central shaft, the drive shaft of where I'm coming from. So to make my life easier, I'm actually going to operate from the new plane. I'm making good use of this. So if I bring it in, I need to remind myself what the hell I was doing, because like I said, we're going to come back to this. So I'm going to call it drive shaft. Bring in from the new plane. So sketches into there. Then all I need to do is I want to put a circle on. And if anyone's been listening, which you better blooming had have been. In fact, look at that. That's a mistake. So I'll call that external ring, and then I'll map that in again and call that internal ring. Right. So it reminds me. It tells me, yep, I can use that one straight away. So I'm going to bounce that straight in. Now I've got scent ring. Scent ring is not what I need at this point, so I'm going to drop that right out. So all I've got now is a standard circle, but that's giving me the center point. But I need my drive shaft. Now I remember I've gone shaft. So I'm going to go shaft is equal to, now bear with me, let's have a measure to see how much the standard shaft is. It's actually 5.1, so we're going to go 5.1. The reason we're putting all these in is it leaves it wide open for us to control it afterwards. But again, we're not doing that in this tutorial. We're just getting the thing into position. We're getting comfortable with what's going on. Right, so onto shaft, got the shaft, and then let's come down to here, and center point, we come here, and then we'll go plus shaft over 2. Again, because I'm putting it in as a diameter when it's actually a radius that this can project from. So let's get rid of that, and then let's run it again into standards. Nice. So I just want to check that. So let's go in for a dimension. Okay, so let's go into that dimension, and then let's just check my units, because it looks like my units are wrong, but I need to just be sure. 5.1, nailed it. So that's perfect. In between here and here, we often find journal bearings to help it to be used. If you were going to do something like this for your assignment, I'd expect these details there. Also, there is a fillet on this edge. If you're wanting this for your assignment, I expect that fillet to be there. I'm only going to do a very basic one to get you guys thinking about what we need to do. So, I need an extrusion. Now you'll notice now, I don't really have to keep going back to record that process. All I do now is I go up and go, right, there's a cut, it's not what I'm after. And you look there, and you go, right, that is what I'm after. So I'm going to copy that, and I'm going to paste in. It's nice. I know what's going on. You know, I don't need to worry. So we've got shaft height. So let's establish shaft height, and then let's go shaft height is equal to shaft height over 1,000. Again, we've got this units area. Units area is incredibly important for what we need to do. So all I do now is come back into here and then go paste and paste. Right. So the last thing that we don't have yet is we don't have a shaft height. So let's go paste, and according to this, so bear with me ladies and gents, according to this we have we're gonna go 25.2. We can round this down, we can do whatever, but it just allows us to record the hard. So we've got 25.2. Obviously, if we were going to manufacture this, we'd need to look to refining this even further to make sure that we weren't making any embarrassing mistakes. So let's get back to it, and then let's run it. Okay. Run it through, straight to extrusion, profiles in, cuts, point piece, and shaft. And there, ladies and gents, is our basic stepper motor. The mounting points are correct. This component now should be useful for us to be able to figure out any types of designs, any types of positioning. If we need to move further into this, if I'm going to produce this for something that needs to go out there or needs to be specific for size-wise, I would then need to include further. Now I may include further. I'm just conscious that this might end up being people's assignments, and I don't want to end up doing this. It's a cracking example, but yeah, so I'm just going to debate on which way to go with this. So, if you found it a benefit, I hope you found it a benefit. This is our first step in getting the stepper motor housing, just to give us an overall geometry representation. What you should have is this. This is a nice clear example. Now there's loads and loads and loads and loads of what ifs on here. So what if the housing changes? What if the standard changes? What if these holes are slightly different? Is there a standard to operate to it? For me, that screams, and I mean screams out case statement. We're going to use that. We're going to put some further details into this. I thought it was a great example. Rather than just randomly building more and more stuff, we can base it on real examples. And actually, personally, I really actually need something like this at the moment, because I'm involved in a project where we're essentially using this type of thing. What I'd like to do as a final thing with this plane, I don't like it being there. Nobody likes extra bodge bits being there, so I'm going to left click on it, going to hide it, going to hit stop, going to put it on my dummy, and then if I just replace that, what you'll notice is that the plane itself is set to a toggle. So I'm going to come onto here, onto dummy, look at that, plane 1, blank geometry set, and I'm going to go copy, straight into here, get down to the bottom, paste that in, and to remind myself what the hell it is that I'm looking at, I'm going to bring that across and say hide plane. So if you've not done already, hit save. We are going to revisit this. I hope you found it a benefit. I hope it gave you a bit of an idea of getting started. Getting started on these things is tricky, but as long as it's give you just a basic insight to moving forwards. Like I said, we are going to revisit this. I would like to put, because anybody who knows, you'll know there's magnets that sit around here, or the coils sit around here, and it ends up with a different black profile. This I'd like to add, and also beneath we have the mount holes here. Now the mount holes, the great thing about them, sits on the same type of profile as here, so it begs the question, can we use the same direction as what we've presently done? Answer, yes we can. So I hope you found it a benefit, and I will speak to you all in class, raring and ready to go for API, and I'll speak to you all soon.